In exercise number 3, we're going to learn how to calculate the superelevation transitions for our multi-lane divided highway using the superelevation XML preferences file that we had set up previously in exercise number 1. And we'll also take a look at how we can review the superelevation data by creating a superelevation report. Now before we go and actually calculate our superelevation, I just want to point out that there are a couple different ways to perform the superelevation calculations. The first method is a rules-based method that uses the superelevation XML preferences file that we utilized in exercise number 1. And when you use the rules file, all the calculations are based on the tables and the equations and the variables inside of that rules file. So since that option is rules-based, then any changes that are made to horizontal geometry will automatically update your calculations. Now, you can also enter superelevation slopes and transitions manually without using the rules file. And this is more of a manual process, so we have some other tools where we can import spreadsheets, we can insert stations and cross slopes manually, and also use a superelevation diagram to enter our superelevation. Now for this particular example, we're just going to be using the rules-based method where we're going to be utilizing the superelevation XML preferences file. So in the previous exercise, we've already gone ahead and created our superelevation section and our superelevation lanes. So now what we're going to do is we're going to create our transitions and apply our transitions to our superelevation lanes here. And the design speed for this particular corridor is 70 miles an hour and our Emax rate is 6%. And the pavement's going to be rotated about the inside edge of our pavement here, or the inside edge of our lanes. So let's take a look at how we calculate our superelevation and apply it to our superelevation lanes. So we go up to the superelevation panel here and we select calculate superelevation, and you're going to see the calculate superelevation toolbox appear. You're also going to see the heads up prompt attached to my cursor. It's going to be prompting us to locate our first superelevation section. So I'm going to come over here and select my SR97 superelevation section. I'm going to right click to complete that. And then for the standards file, you're going to see it's going to be prompting us to select our AASHTO 2011 Imperial XML rules file. So I'm going to press the Alt key and the down arrow on my keyboard, and I want to select the one that I have in my Bentley training folder here. So I'm going to go over to Bentley training, using and defining superelevation. I'm going to select my AASHTO 2011 Imperial XML file, because this is the file that we edited when we started this in exercise number 1. So I'm going to select that, click open, and that defines our superelevation rules. So I'm going to left click to accept that. Now our Emax, once again, we're using a 6% rate here, so I'm going to keep that set for 6%. And then for our L selection, we want to do our L selection based on a speed table. We also have the option to do the AASHTO equation method. We're just going to use the speed table. And for the design speed, we're using 70 miles an hour. So I'm just going to key in 70 miles an hour here. Use the down arrow to select 70 miles an hour. And the pivot method, this one's very important because we want to pivot about the inside edge of our pavement here for both sides of the road. So our pivot method, I'm just going to toggle down. You can see there's many options here. We got inside edge, we have outside edge, we have left edge, right edge, we have divided inside, we have center line, and we have crown. So I want to use the one that says divided inside because we're working with a divided highway and we're going to be rotating our superelevation about the inside edge for both sides of these roadways. So I'm going to select divided inside. And I'm left click. It's going to prompt us, do we want to open the editor? I'm just going to say no. And left click. And it's going to go through and perform the superelevation calculations and assign them to our superelevation lanes. So I'm going to right click to get out of the command and zoom out, and we'll take a look at some of these curves here. You can see we now have some different colors along our lanes. That indicates that there are various slopes that exist for our superelevation transitions. Now in this particular example, the design rate or design superelevation rate and the superelevation runoff are calculated using the values in the AASHTO 2011 superelevation tables for design speed of 70 miles an hour and an Emax of 6%. So that's where our calculations are coming from. And once again, those tables and equations exist inside of our XML rules file. So we just kind of browse through and review some of our curves, you can see all the different colors indicating the different slopes that are happening along our alignment. One way to review our slopes is to simply select one of the superelevation lanes. And when you select one of the lanes, you'll see the dynamic text show up indicating the stations and the slopes of the various superelevation transitions. So you can see here, if I zoom into this curve, we have a 2% slope at this particular station, and we're transitioning over to a 0% slope and back up to full super here. So just by simply selecting a lane, you can review some of these slopes and these stations. So now once you have the calculations assigned to the lanes, the next step would be to review your superelevation report. You may want to check the calculations, you may want to check the slopes and the stations, make sure everything looks like like it's supposed to look. So we're going to do that by using our superelevation report. So I'm just going to come over here and select my superelevation section. From the context menu, I'm just going to go over here to superelevation report and select superelevation report. That's going to bring up the default superelevation data report. So this is a special style sheet that's just set up by default. And let's review some of the information that's inside of this particular style sheet or report. So you can see up at the top here, it gives you your section name. It gives us the standards file that we use to perform the superelevation calculations. It tells us the design speed that we used. It tells us the pivot method or the rotation method that we used. And it gives us our Emax selection as well as the runoff length selection. So you can see we use the speed table, and then it's also giving us the name of our superelevation lanes here, and then also the stations, the cross slopes, and the type of transition that we have applied to our lanes. So some very useful information here in a report format, giving you the exact stations and cross slopes of your superelevation transitions. Now, another report that you can take a look at if you're more interested in the actual calculations is going over to the superelevation calculation style sheet, and you select this file here, and you can see some more detailed information. You can see some of the offsets, and you can see some of the other values that you may be interested in relating back to superelevation. So you can see the actual transition lengths are listed here, and some other information that you may find useful. So it's usually a good practice to go through and review these reports, make sure everything is calculating appropriately. So once you're done reviewing your superelevation calculations, you can come over here and you can print this out, or we can save this to a text file. So once you're done reviewing the report, then you can just simply close the Civil Report browser.